First of all, I would like to thank all of my colleagues here around from the other truck manufacturers in Europe who gave a tremendous support for this presentation. So it's not only a Daimler presentation, it's using a lot of arguments from our other truck manufacturers here in truck and bus manufacturers here in Europe as well. The presentation really is trying to focus on a theoretical approach, showing more or less latest EU truck technology, using the different models from the other regulation activities, mainly the one in Japan, then the other one in China, and the third one certainly in the US. So it's a theoretical approach, and I have to say that clearly many of those points are based on those simulations. We were not able really to run all that in a practical operation. For example, we did that for China. We were running a truck on a chassis dyno test and using the Chinese WHVC cycle. So some of them are on practical, but many of them, or most of them in fact, are based on focusing on simulation results. Therefore, there are many limitations, that is clear, but I think that the overall results are quite impressive on the one side, but also on the other side helpful for your activities. I think Michael has shown this slide already. I think it's not necessary to go in every detail, but what you can see is really since the 1990s here in Europe, we had what we call the Euro era for more or less 2 decades. We're running from Euro 0 to more or less Euro 6 now. We were even able, you see one of those graphs here, we were even able to reduce the fuel consumption during that time, although most of the activities went into the reduction of the what we call criteria pollutants, the NOx and the PMs. There is one big green point at the very right side. You see that is a point on what we call the latest EU truck technology. It's a bit provocative to say that clearly in that way, because that first of all is showing that a truck we're running on 10,000 kilometers in real life operations, let me say start and stop, heavy rain, very congested from Rotterdam to Stettin in Poland, and we have shown in 40 tons, by the way, 26 liters more or less fuel consumption. But we have to admit this number is not really comparable to the cycles, the routes which are used for the other dots in that slide. And I think that shows the dilemma already. What are the comparable cycles? It's clear we can show today a truck with 40 tons of less than 26 liters in Euro 6 technology, but the same truck can even easily have a fuel consumption of about 30 liters. So the dimension really has to be developed in terms of what is the right long-haul cycle, and this is certainly a task we all have here in Europe. Not only the manufacturers, I think more important the regulation side. Next slide. We often discussed today and in previous meetings, is competition working? At least from our side, we believe, yes, it is working. We've just taken up a comparison of the what we call in Germany Lastauto Omnibus magazine, which is one of the leading magazines in Europe with regard to trucks and buses. And what you see is between the worst and the best is just around 4.5% difference in fuel consumption. And there are other comparisons where even between the worst and the best just only be 2%. So that means for us it's very, very competitive, and you can see easily once when a new truck is coming up, this truck is leading and the other manufacturer have to follow immediately, otherwise they are out of competition. Because, and this is the left side of the graph, because the fuel is so important in Europe. We count roundabout in an average of 35%. There are markets in Germany, in Europe, like Germany, where you have very expensive drivers, then the fuel costs are a bit less. But there are other markets where it's much higher because the drivers are much cheaper. Next slide. We have seen, and that is really was surprising to me on one side, but I'm very thankful on that, these activities in Japan on the integrated approach. I think we have to deliver all potentials and not only focusing on the vehicle itself. In 2010, we made a comparison between an old truck, what we call an old truck, model year in 1965. It was hardly be operated, and to be operated was very difficult, and the drivers didn't like it because they know what the advantages of today's trucks are. But we took them, both vehicles. You see the LP 1620 is on the left side, and on the right side the latest version of the Actros at that time. And we took those two vehicles fully loaded over the Alps, both forth and back to Milano, around about 1,200 kilometers. And what you really see is the driving time on the left side, 20 hours, and the other side was 12 hours. The average speed of 58 kilometers, and on the right side is 76 kilometers. That is really an advantage for the society. That is not raising the costs, that is reducing the costs. And if you take into account into the equation the payload, on the left side 16 ton and on the right side 25 tons, that really shows what we have achieved during the last decades. But that was clearly because we were able to raise the payload by a certain amount of tons. And we were able to raise the speed for the advantage of the society because getting the transportation costs down. And if you then count, let me say, the results and calculate the results, then you see on the left side, starting again with the fuel consumption, for some reasons during the measurement procedure, it came down only, I have to say, about 15%. We believe it's a bit higher, but for those measurements, it was not so easy to take them because sometimes the trucks the old trucks had to be stopped and so on and so forth. But anyway, 15%, we've taken this number. We reduced from 37 liters down to 32 liters. But then taking into account the fuel consumption per ton, and you see that in the middle graph, then you see that it went down from 2.3 liters per 100 ton kilometer down to 1.27 ton kilometer. So we were able to reduce per ton, per transported ton over that period and distance by 46%. We were nearly halving the total amount of the fuel consumption, the CO2 emissions. I think that really shows the overall what we have achieved by taking the integrated approach because of getting higher payload in. That was a success in that respect as well. Coming more to the regulatory activities around the world, I think it's not necessary to go in every detail. We've got brilliant presentations this morning on China and Japan and the US. More important for us here is really the left side of the graph is the timing period. If you have a look on what the American standard is focusing, it's clear 2014 to 2017, and then it's lasting usually for 3 years. So by 2020, and it is written in the regulation, is a phase 2 program starting, or should a phase 2 program starting. If you go to China, we have heard that by the end of 2013 there should be a national standard in place, but that's for, at the moment, at least to our knowledge, 3 different categories, maybe more coming up. So once when we have learned, it's clear, so towards the end of the decade, more or less all segments might be in that standards. And we have heard also that Japan has a regulation in place started 2015, but we have heard also that they are tightening the standards, or that discussions on tightening the standards are ongoing. So that means by 2020 there is another possibility. And then it's unclear what we are doing here in Europe. A CO2 measurement procedure might be one aspect. You know that we believe in ASEA that we should have a CO2 declaration procedure, something like that. It will turn out somehow, but there is, I think, a really good chance, and this question has been raised today as well, that by the end of the decade there could be a harmonized act on all of that. We should really work towards that, taking the possibility really what is possible in terms of harmonizing the most important parts of all those components we need to improve the fuel efficiency of our vehicles. Because in the situation where we are today, we are customer driven. Today we are optimizing, and Byron mentioned that the customer comes into our shops and there's a discussion ongoing, what is the best drivetrain, what is the best shape of the truck, and then we optimize it according to the different specifications. Once when a regulation is in place and the regulation is not being carefully developed, then we have to focus first on the regulation. All of our experiences so far are clear. In the PES car side, you know, we have two different activities. One is, first of all, following the different cycles and showing to the customer on the basis of the cycles the results. But we also speak about what is the real life consumption of the vehicle. I think this is the same here for trucks, or even more important, that we really keep an eye on that. If a regulation is in place, it should not jeopardize the results and the effectiveness of the customer-OEM relationship. And for that, I think it's really our belief, and we really work on that very hard, that a CO2 declaration procedure which gives the customer a comparable result, what are the, let me say, the efficiencies of trucks from different manufacturers for the same configuration in a very short and let me say acceptable presentation or simulation, the chance really to decide later on that. That's really very important for our business. So going more into the details of the different measurement or activities around, I just wanted to present you a short overview about the key factors, the key criteria of the regulations. We have heard, for example, in the US we have a gram per ton mile approach. In China it looks like that we get a gram or a liter per vehicle kilometer. In Japan we have already a gram per vehicle kilometer, and in Europe we believe that the gram per ton kilometer should something be what we are focusing on. In the US we are working, as said from Byron, we have a separate engine standard and we have a vehicle standard. So we have to do that in a different way. In China we have heard that we are working on a chassis dyno testing procedure, and then for the key type, and then we get a simulation for the variants. In Japan we have a simulation, but it's based on drivetrain measurement procedure, and in Europe we have a certain procedure, or we propose a certain procedure which should be used as, let me say, as a blueprint maybe. Simulation input data are very important in that respect, where do they come from and how they are measured. I think this is very decisive, and later on I think it's very important to get let me say, a segmentation and cycles which are covering the broad industry in a way that that the fuel efficiency can take place, or fuel efficiency improvement can take place. I would now focus on the simulation results, just highlighting the situation in Japan. You see that the borderline, or the bottom line of this approach is that you have to measure your engine on an engine dynamometer. You use fuel maps and some other information from the specific vehicle as well, but aerodynamics and rolling resistance are used from default values, so it's mainly focusing on the engine. And this is certainly one of our limitations as well, and maybe you go on the next slide. It's one of the limitations from our side, because once, if you are improving the vehicle in total, then as a manufacturer you can select what is the most efficient one. But when the standard is only focusing on the engine, you just have to focus on the engine. All the other possibilities are more or less not really effective. The one who puts the most efforts into the engine is the winner, and the one who really optimizes the vehicle, maybe in a much better way for the benefit of the customer, would be the loser. So in that respect, I think if you now take, that was in the beginning, if you now take the Euro 6 engine on the right side and from our European experiences, and you put it in the Japanese tool, then you see that we can fulfill the requirements of the FES standard in Japan. That really gives you more or less the information that in Europe we could get the fuel efficiency standard 2015 already today. There are many limitations, many boundaries to be mentioned. You know that in that class, in that number T11, in that category T11, it's 70% city and 30% highway. This is certainly not what we optimize our engines for. But anyway, it shows you that even under those restrictions, our Euro 6 engine is able and is better than the current FES standard. Next slide. Coming to the Chinese activities, you have heard about the activities. On the right side, you see the limits, the proposed limits for the moment. We don't know whether it's the final limits, but for the proposed limits in this tractor-trailer category. And you see our categories here in Europe, less than 40 tons, then the limit is 47%. As said, we had to simulate that. If it would be a key type, then we would have to do it on the chassis dyno test, but that we have simulated. Maybe in the next slide you see then the results. You know that for the Chinese activities in that category, they propose 10% interurban and 90% highway. You see that Euro 5 and Euro 6 engine, the current Euro 5 vehicle and the Euro 6 vehicle, and what you see here is in a combined cycle we would achieve in that a fuel consumption of around about 37 liters, and the target right now is 47 liters. So we are well below the target. Certainly, I think it's clear this is an European vehicle. The Chinese WHVC is a bit restricted in terms of power demand. That gives us certainly some better efficiency. But anyway, I think the overall results should show that we are much better than the current limit is, although it's clear it's European technology, and that's a bit, it's clear. Coming on the US standard, I think I could, let me say, talk very long on that, but I think what has not been mentioned today is really that we are now in a situation that it's not only on the truck manufacturer to fulfill the standard, it's more on the choice of the customer. If we now focus, let me say, on what we can do to optimize our vehicles with regard to the aerodynamics, I think that's definitely be done or will be done as well, but it will not be enough to fulfill the standard. So we need the right choice of the tires of the customers. We need somehow a take up of the idle reduction. We need certainly somehow take up of the weight reduction, and not to speak about the speed limiter. You know, it's clear, it's more than ever that the customer takes it, and if the customer doesn't take it, then we have to restrict somehow, let me say, in a certain way, the the equipment of the vehicle, so we must force then the customer to take it, otherwise we would not be able to fulfill the standard. So it's really a new element. The customers were used to have all those activities on the ancient sites. This is not very new to them because they lived with EPA 4, 7, 10 and so on and so forth. But now in this situation, really in such a short time to convince the customer that he has to take these tires, and that he have to take, let me say, some idling reduction and speed limiter, this is new to them, and we hope that it will be fulfillable, but it's a certain challenge to us. And another thing is certainly if you focus, for example, on the speed limiter, I think it's clear if the customer takes the speed limiter up, and we just spoke about it, as he is mileage driven so far, then and you reduce his let me say the speed of the vehicle, it will take longer for him. So he has to work longer for the same, more or less for the same money, if he drives the same distance. This is certainly a challenge, and we will see whether the customers will take that up. And then the next slide really now comes up to the simulation results. And again, it's not very easy to understand, and that's the reason why I'm staying a bit longer on that slide. There is a baseline in bin 2, so to say, and standard, and 2014, and then where the US trucks are, to our opinion, more or less today. You see the blue point, and it's clear, and I really would like to outline that the aerodynamics of our US trucks are better than the referring European trucks. This is not to be doubted, but if you take into account the huge trailer gap, then all of the improvements of the shape and the aerodynamic of the tractor are more or less compensated by the trailer. You just mentioned, Michael just mentioned the trailer gap of 85 and around about 1 meter between the trailer and the cab. I just checked it with my colleagues. We have around about 58 centimeters right now between our cab and the trailer. 58 centimeters. This is more or less half of the dimension of the US. And this is, so to say, really one of the things we really have to do. It's very seldom that I'm in line with yours, but this time I think I'm absolutely in line. We have to improve the situation on the trailer side, otherwise the fuel consumption will not go down in that way. On the right side you see the tires. I think Byron mentioned it. Yes, we had to learn what is the rolling resistance of our tires. Some of them we knew, but certainly not all of them, and I don't have the exact numbers of tires in the US. In Europe, I know we have 2,000 different tire sizes in our plant in Wörth. So 2,000 different. I think that shows really the challenge to us, and shows also the challenge to the tire industry, because we fully rely on all those measurements from the tire industry. We checked that with our tires we are using on our European truck, and I can tell you we are right now much better. I think the other points are not really so surprising. If we have idle reduction capabilities, we have all the components on board. We don't need to idle the engine, what you have in the US, and the weight is not so important. So we are comparable, I think, to the US standard. Next slide. Coming to the ancients, I think this is one of the challenges, and what we've tried is really a differential picture between the Euro 6 engine and the EPA 10 engine. With all those restrictions, I have to say that it's clear that the EPA 10 engine has somehow a bit stricter NOx standards to be fulfilled. You know, Euro 6 is a bit less stringent than than the EPA 10. The cycles are different, and so on and so forth. So with that restrictions keeping in mind, we still can say that at least the Euro 6 engine is absolutely comparable or even a bit better than our EPA 10 engine. I think this is the message of that picture that really shows what we have done. And as you know, 2014 is our Euro 6 time. It's even so that we can show that we are on that track as well. One word on that, I think, is really important to say. The best point, the peak point of our engines right now, and I think they are all manufactured quite close together, is around about 46%. 45, 46, this is the value we all know. And it's very, very difficult really to go up to 50%. Byron mentioned this super truck program. We all strive for that, but it's still on an, let me say, on a prototype basis. It takes a long time and a lot of money really to get from a prototype standard up to the series standard. So we should be very cautious with applying 50% or even more towards 2020, having that in the truck. Although we know that if we improve 1% in the engine, the thermal efficiency, that has to be counted by 2, so it gives you around about 2% improvement. And finally, next slide, please. It's the fact that if you take everything together and you'd go for the EPA 2014 standard and using different specs, some specs are not fulfilling it right now. In the US, some are better, some are much worse. I have not showed them, but I can tell you, and this is more important, if we use all the boundaries given by the GEM model, this is very important, and all the limitations, so to say, then the latest EU truck technology goes down to 56 gram per ton mile. But saying clearly the US trucks are used on 65 miles per hour speed. We are using 55 miles. This is certainly a bit different and an important difference, but Michael showed already roundabout if you take all the differences, it's easily to count that there are 20% difference between, if you take that all into account, between the US and the other ones. And that goes then really what is possible, and we just could shortly outline that. You know that in the Lot 1 study made by Ricardo, there were also an overview on the technologies which are available or which would be available. And I think just running through electric vehicle and a start-stop system for long haul, that doesn't really make sense. It's clear the battery would cope fully the payload, and there would not be even 1 ton to carry the goods. And then there are some yellow dots to say for a full hybrid. I agree. It's technically wise, it's possible. It's not a question, but the question is really how cost effective that really is. And for today, at least to our belief, it is not yet cost effective. Maybe the batteries go down, the battery costs go down quick enough. And maybe our customers accept that the lifetime of such a drivetrain will not last for 1.2 million kilometers. Then we might see that a bit sooner, but right now it's really not a cost-effective technology. And on the other side, many of the technologies which are used for 2020 in the Ricardo summary, they are already in our vehicles. So we can't get this potential again because they are already equipped into our vehicles. So from that perspective, I think we have to be very careful what is the technology improvement rate, and most important really, what is then the reduction potential. Next slide, please. That brings us back to what is really possible. One thing is certainly what we mentioned already is this measurement procedure and the declaration procedure. We believe this is really a big step forward, but there are other points in the vehicle operations. We had yesterday a lady from IKEA there that many things are done already, but there are a lot of things possible, and we need to focus on that as well. Driver training is a very, very important thing. We have equipped our vehicles with a driver information system, but there's still a lot of potential in it. So driver training is a very important thing. Alternative fuels, I know that the Commission, at least a part of the Commission, doesn't like the biofuels, but it's an issue. There could be a chance really to improve the overall situation. New vehicles is one point, replacement rates, especially in the delivery sector, vehicles are becoming older and older because the, let me say, the economy is not very good in that business. But exchange of old vehicles to new vehicles would be a good thing or a big thing. But as said, the trailers are really one of the potentials which could be leveraged much, much faster. Looking a little bit on the time, really the recommended principles, I think it has been discussed today. We need something where the customer really gets a better picture on the entire system, and for that a simulation procedure with measured input data would be a good chance really to inform him. Next slide. Finally, I would come to my favorite slide. This is really, as said, we see many differences in the different activities around the world. The greens on the European side doesn't mean that everything is good in that respect, but I think in that direction we could move. It's not that everything, as said, should be taken up of that, but finding good compromises on how to harmonize the different activities. I think this should be really possible. Why are the simulation tools so different? Why do we need really to measure the specific engine and to show that shouldn't we integrate the engines into the entire vehicle system? This is how we optimize. We have different metrics. As said, some of them are using gram per vehicle kilometer and the other one is using gram per ton kilometer. And so on and so forth. I think there are huge possibilities really to optimize that. And if you show the next slide, please. Then it's clear that harmonization of those activities could really be to the benefit of not only the customer, but also for the society, and finally also certainly for the truck manufacturers, which have to provide all the money to develop those vehicles. What can be harmonized? One thing is certainly the cycle definition. We do not talk about that we should harmonize the cycles. This is definitely not the way we want to go forward. We need to find a way that we need to integrate the slope. We need to integrate load, and so on and so forth. In some markets, we see that we have a speed over time vehicle definition. This is not what we really need for our improvement of the heavy duties. The measurement methods, I think, could be harmonized. How to measure the aerodynamics, I think this is equal for all of us around the world. Tires, we still have different tire standards. The fuel maps, how to do them, the fuel maps, I think, could be harmonized, and so on and so forth. The simulation tools, it's clear everybody wants to develop its own simulation tool. I can understand that, but isn't that for the benefit of the society? Question mark. You can give the answer. And on the other side, it's clear, for example, the US will continue to drive 65 miles, maybe. In Europe, it's 55 miles or even less, so it doesn't make sense to harmonize the cycles. The segmentation is different. You have different segments in the different areas. For example, in Japan, we have a 25-ton segment and not a 40-ton segment, so it doesn't make sense really to harmonize it. But how to do that, I think that could be harmonized. Yeah, then coming to the end, I think all simulations have shown that that Europe can compete with the other markets. There is not really a market which is much better than the European vehicles. We have given full attention to improve the fuel efficiency. As said, it was the nature because of the high cost share in the total cost of ownership. The ASEA approach of a certified declaration of fuel efficiency offers the customers the guidance in terms of real-life results. And as said, this should not be underestimated. Don't forget, trucks are not just bigger cars. Trucks to serve our society, and everybody of us is affected if freight costs are rising. In these days, more than ever before, we must make sure that everything what we do is cost effective. Thank you very much.
Thank you, Mr. Schuckert.